Okay, let's try the next question. It says minus 6x squared there. Determine f prime of x from first principles. Well, that's a straightforward thing. I like to do f of x plus h minus f of x, where you take x plus h and put it in the function, work it out, subtract f of x, which is minus 6x squared. Now, when you've got that, it makes the next part a little easier. F prime of x is, the derivative is a limit as h approaches 0. Here's the formula that's in your formula sheet. Now we've worked out the top part, f of x plus h minus f of x, and you just write in minus 12x h minus 6h squared. Now this h cancels with this h, one of these h's cancel. You're finding the limit of minus 12x minus 6h over h, and the limit as h approaches 0 of this thing here. Well, now, what happens if h approaches 0? Then this thing, which is really a gradient, just becomes infinitely close to minus 12x, and there's your answer. Now, how would you restrict the domain of f to the domain of this? Ooh, all of a sudden we're into inverse functions. How would you restrict the domain of f such to make it a function? Well, there'd be two ways you could do it. You only want one branch. It's just an unhappy parabola. You can take the right-hand side where x is greater than 0 or the negative side. So now if you do that, they say, what if you said determine the inverse for the inverse being less than 0 in the form of y equals? Well, here's the equation, y equals minus 6x squared. And that's this unhappy thing. Now they're saying if the inverse is the negative part here, we must have restricted it with x being less than 0 to start off with, okay? So that's kind of what you do. You switch x and y, and then you divide by minus 6, and you take the square root of both sides. That's what we want here. We want this function here, the inverse is equal to this, where x is less than or equal to 0 on this side right here. That's the inverse function right here, f prime of x, where x is less than or equal to 0. And that's the question all done. There we go.